Happy day students. Welcome to San Academy Group of Schools, Pallikaranai, Grade 8 Science. Today we are going to discuss Chapter 11 Force and Pressure. So what is force and pressure? Force can be defined and studied only through their effects. It is present in all parts of the universe. It was Aristotle who first studied the motion of an object. He believed that a force is required to keep an object moving. But Galileo proved that if an object once comes in motion, it continues its motion forever. If there is no friction between the surface, this tendency of an object by which a moving object keeps on moving was named as inertia by him. Galileo's work set the stage for Isaac Newton when he developed the three laws of motion. He put these three laws in his famous book, namely Philosophiae Naturalis Principia, Mathematica. The Latin title means Mathematical Principles of Natural Philosophy, often simply known as Principia. The first law is restatement of Galileo's concept of inertia. The second law relates acceleration to its cause, force, and the third is the law of action and reaction. The force acting normally per unit area is called pressure. Liquids and gases both flow when a force acts on them. Fluids, which include both liquids and gases, play an important role in our day-to-day life. Life is not possible without them. We breathe them, drink them, and cook our foods with their help. The force exerted by the atmosphere is envelope of air surrounding the earth. Per unit area on the surface of the earth is called atmospheric pressure. With this introduction, let us get into the topic. So, what is force? Force is nothing but a push or pull of an object. So, generally, force can be defined as a push or pull of an object. So, force is an external agent. So, what is this force? This force is an external agent which changes or tries to change the state of the object. As you can see here, it changes or tries to change the state of an object. And note that when we say force, we imply the total force or the net force acting on an object. Generally, more than one force act on an object. For example, when a ball is sailing through the air, the force of gravity and air resistance both act on it. The net force on the ball is the combination of all the forces. It is the net force that changes an object's state. If the net force on an object is zero, it will remain in its original state, about which we will be look in detail a little later in this topic. So for example, actions like picking, opening, shuttling, kicking, hitting, lifting, flicking, pushing, pulling are usually result in some kind of change in the motion of an object, and that is known as force. So, a force cannot be seen, but we can feel and observe the effects of the force. So, we cannot see the force, but we can feel the force and we can only visualize the effect. For example, here you can see that a force is being exerted by this magnet, as a result of which the iron nails have attached to the ends of the magnet. But the force exerted can't be seen by us, whereas the effect of which, as a result, because of which effect the nails are attached to the ends of the magnet, and that is what we are stating as the effect of the force can be observed. So let us have a quick refreshing of the concept. So force is nothing but push or pull in various activities. Here you can see a boy pushing or pulling. What is he doing? He's pulling a trolley. Whereas here you can see the boy again pulling the dog. What about here? The boy is pushing the ball and the girl is pushing the swing on which her friend is sitting. And you can see here the boy is again pulling the cart, whereas here the boy is again pulling the fishing rod in order to catch his fish. What are the effects of force? So you can see here a man is using force to move the stationary lawn mower. So one effect of force is we can move anything which is at rest. And here you can see a cyclist is using a bigger force to pedal his bicycle and increase in speed. So we can say the another effect of force is it can increase the speed of the moving object. Coming over here, you can see a boy playing football and he uses the force in order to change the direction of motion. So that by applying force, you can change the direction of any object into a different direction in which it is actually moving to a direction in which you want it to move. And coming over here, you can see a baker using force in order to make his dough into the required shape in order to make a curry puff. So force can also be used in order to change the shape of an object. Now, let us move on to the next slide. So, can a table move by your presence? That is, just by standing nearby a table, can you move this table? No, it's not possible, right? The table may begin to move in the direction of applied force. So, in order to move this table, you have to apply force on the table and the table will move in the direction in which you are applying the force. So, you can see here the table will move only in this direction because the person is applying the force in this direction. So, the table is moving in the direction in which the force is applied. So, note that a man has to push the table to make it move. Thus, an interaction of one object with another object results in a force between the two objects. So, for the force to be exerted on an object, there is a need of interaction, that is, two objects should come in contact. In this slide, you can see two persons are trying to pull the table towards them, but the table is not moving. It is remaining in the same spot. And when this will happen, this will generally happen when the net force is going to be same. When will this happen? This will generally happen only when the net force is going to be same. Net force is going to be same. So here you can see the two persons are trying to move or pull the table towards them. But what happens? The table is remaining in the same position or in the same place. And when a person pulls harder, that is applies a larger force, finally he wins the game. For example, if this particular person is going to apply more force and if he is going to pull the table harder, then the table will start moving towards him. But whereas if both of them are going to apply equal force, what will happen? The table will not move at all. It will remain in the same spot. And this gives us a hint that table will move in the direction in which the net force acting on the table is going to be higher in amount or greater in amount. So here you can see children playing tug of war, and all of you would have played this game, right? Tug of war. So the concept behind this game is also the same. When the net force applied by both the group of the children are going to be 0, the rope will not move at all. For example, if this team of children are going to apply more force, then finally they will win the game, because the tug of war is a game where you have to pull the rope towards yourself, and for which you have to apply greater force. So if two forces act in opposite direction on an object, the net force acting on it is the difference between the two forces. For example, if team 1 is applying more force than team 2, then the net force will be the difference between the force applied by team 1 and the force applied by team 2. Now, when both of you were pushing the heavy box from opposite direction, what will happen? What will happen? Does it mean the net force on the object is 0 if the two forces acting on it in opposite directions are equal? Exactly, it will be 0. For example, if this boy is also applying the force of 5 Newton and this boy is also going to apply the force of 5 Newton, the door will not move at all, because as I told you, in order to calculate the net force, we have to find the difference between force 1 and force 2. So 5 Newton minus 5 Newton is going to be 0. Hence, when equal amount of force is applied on an object in opposite direction, the net force will always be 0. So fact is, a force could be larger or smaller than the other. The strength of force is usually expressed in magnitude, and we have also to specify the direction in which force acts. So also, if the direction or the magnitude of the applied force changes, its effect also changes. That is, the direction in which it is going to move and the effect or the change what is going to happen on the object will also change. So now let us discuss about net force and how it is being calculated. So as you can see in this object A, towards your right side the force applied is 8 Newton, and towards the left side the force applied is 2 Newton. So only towards the right side it has greater force, so that automatically the object will move towards your right side. But how are we supposed to calculate the net force acting on A? Let me explain it to you. In order to calculate the net force acting on A, you can write the object A is equal to the difference between the two forces acting on the object, 8 Newton minus 2 Newton, and which is equal to 6 Newton. And this is what we have got over here in this picture. So now, can we calculate the net force acting on object B? Here you can see that both the forces are acting on the same direction. So what are we supposed to do? We are supposed to add both the forces. So always remember, on a particular object, if two forces are acting and if they are in opposite direction, we have to subtract the value. Whereas if the two forces are acting in the same direction, we have to add the value in order to calculate the net force. So in object B, since both the forces are acting in the same direction, to calculate the net force, we have to add both the forces. So it will be 10 Newton plus 2 Newton, which is equal to 12 Newton. Now, let us discuss about object C. You can see that on object C, the forces are acting in opposite direction. But in both the direction, it is the same magnitude of force. So what is the result? No net force at all. Because we know if the forces are acting in opposite direction, we are supposed to subtract the value. So let us see the calculation even for that. So object C, we know it is 8 Newton subtracted from 8 Newton. So what will be the
net force. Net force is going to 0, and which indicates that the object will be at rest or it will be in the same position. Now look at object D. You can see that towards the left we have a force of magnitude of 10 Newton, whereas towards the right there are two forces but acting in same direction, that is both the forces are in right direction and the sum of it makes 8 Newton. So, in which direction the object D will move? Obviously, it will move towards the left, because though only single force is acting in the left side of an object, but it is greater in magnitude compared to the two forces acting in the right direction. So, now let us look into the calculation for this. So, object D is equal to force acting on one side, that is left side, 10 Newton minus 5 Newton plus 3 Newton, which is equal to 10 Newton minus 8 Newton, which is equal to 2 Newton, and the object is going to move towards left direction because the magnitude of the force acting on the left side or towards the left of the object is greater. Now let us discuss about what happens when a force acts on an object. So these observations suggest that force applied on an object may change its speed. The force applied on an object is in the direction of its motion. The speed of the object increases. That is, if the force is applied in the direction in which an object is moving, the speed of the object will increase. Suppose if the force is applied in the direction which is opposite to the direction in which the object is moving, then it will result in the decrease in the speed of the moving object. So effects of force, as you can see, we can throw a ball, we can fly the kite, we can use it for flying the kite, and spring balances in order to compress as well as to expand, to change the shape of the dough, for breaking a tin, and for crushing the sponge. So now, can you lift a vessel without touching it? Or can you lift or take a book on a table without touching it? For example, all of you are attending your online classes. Is it possible for you to open your laptop without touching it? No, right? So in order to apply a force on an object, your body has to be in contact with that object. And the contact may also be with the help of a stick or a piece of rope. So the force that is caused by action of muscles in our body, and this type of force which is resulting due to the action of muscle is known as muscular force. So the different types of forces are contact force, where the two objects between which the force are going to be exerted will be in contact, whereas the other one is non-contact force. The two objects can be at distance. In spite of that, force will be exerted between them. And the example for contact force are frictional force and muscular force. Whereas for non-contact force, it is gravitational, electrostatic and magnetic force. So, types of forces as we discussed just now. In case of contact forces, interaction between the object that touches them. For example of contact forces are applied force, spring balance, drag force, frictional and normal force. Whereas non-contact forces attracts or repel even from a distance. That is the two. There is no need that both the objects should be at closer or they should touch each other. And the examples for non-contact forces are magnetic force, electric or electrostatic force and gravitational force. Coming to, since muscular force can be applied only it is in contact with an object, it is also called as a contact force. Whereas magnets, as we all know, when they are brought closer to the closer vicinity of the magnetic material, they automatically attract them. So it is called as a non-contact force, or we can also call it as a field force. So again in this slide, you can see few examples of non-contact force, magnetic force, where you can see the south and the south poles are moving against each other, which is the example for repulsion act. And the north and north poles are moving against each other, which is again an example for repulsion act. Whereas in the south and the north are attracted towards each other, which is an example for attraction force. Whereas here you can see a example for electrostatic force, where they have rubbed a blown up balloon towards the oil, and then when they brought it closer to the bits of paper, you can see the bits of paper sticking to the balloon, which is an example for electrostatic force. Now let us refresh the concept. Forces, as we discussed just now, it is of two types: contact forces, non-contact forces. And contact forces are muscular force and friction, whereas non-contact forces are magnetic force, electrostatic force and gravitational force. So now let us discuss about an interesting topic. So imagine that a person is trying to push a nail into a wooden block by its head. For example, here you can see a person is trying to push a snowballing bottle into the wooden block. Do you think will it be possible? No, right? But whereas in the second picture you can see a person who is trying to push the nail into the wooden block in such a way that he has kept the pointed end facing towards the wooden block and he is beating on the head. And which one do you think easier? Of course, it is the second one, because the pointed end is quite sharp, so that it will penetrate into the wooden block very easily when a good amount of force is applied on the head of the nail. So now this concept is what we are going to discuss in detail further. And this applied force on the top of the head of the nail is called as pressure. So pressure is defined as the force acting on a unit area of a surface. So you can see over here the entire force which is acting on this particular unit area of surface is called pressure. So pressure is always calculated using the formula force divided by area. So smaller the area, larger the pressure. That is the reason why when the person was trying to nail it on the wall with a pointed surface touching the wall, he was able to do it easily, because the pointed surface has smaller area which is coming in contact with the wall. But when he tried the reverse, it was not possible for him to do it easily, because the head of the nail has comparatively a bigger area than the pointed end. So the smaller the area, larger the pressure on the surface of the same force. The area of the pointed end of the nail is much smaller than that of its head. The same force therefore produced a pressure sufficient to push the pointed end of the nail into the wooden plank. Can you explain now why shoulder bags are provided with broad straps and not thin straps? Because if you are going to have a thin straps in case of your shoulder bags which you are carrying for schools, you will have a severe shoulder pain. For example, many of you will be having rope bags, right? Where the back strap will be just a rope. And imagine if you're going to dump that bag with heavy weight, and if you're going to put it on your back, all of you will feel a good amount of pain on your shoulder. That is because the rope has comparatively smaller area coming in contact with your shoulder. So the pressure will be very high. Instead of that, if that rope is going to be very flat and broad, the pressure will be evenly distributed so that you will not feel the pain. Now let us discuss, do liquids and gases also exert pressure, and does it also depends on the area on which the force acts? Let us find out now. So pressure generally increases with depth. As you can see in this figure, as the depth increases, the pressure also increases. And that is the reason why if you people are living in apartments, you know the person who is living in the ground floor or in the first floor, the water from their bathroom pipes and the sink pipes will be coming with a high pressure. Whereas the person who is living in the fourth floor will be getting the water from his or her pipe only at a low pressure. This is because the pressure generally increases with the depth. That is, the pressures of the liquid increases with depth. Coming to friction. Friction is another example of contact forces. So force that change the state of motion of the object. So this friction is a type of force which will always act in an opposite direction in which the object is moving. So it acts opposite to the motion of the object, and as a result of which it will reduce the speed of the moving object, or it will almost stop the object from movement. And friction is due to contact of two surfaces, and hence it is an example of contact forces. And rough surface have more friction compared to smooth and polished surface. So what is pressure? As we discussed earlier, pressure acts per unit area in the direction perpendicular to the object, and pressure can be calculated as force per area. So now coming to atmospheric pressure. Atmospheric pressure is nothing but the pressure exerted by the atmosphere. And what is the use of this atmospheric pressure? So what is this atmospheric pressure? Whenever we live at the bottom of an ocean of air, that is, we live under the layer of air, and this layer of air which is found above us is called atmosphere. And this atmosphere, just like water, always exerts pressure. And just as water pressure is caused by the weight of water, atmospheric pressure is caused by the weight of air. And we have adapted so completely to the invisible air that we sometimes forget it has weight. Perhaps a fish forgets about the weight of water in the same way. The reason we don't feel this weight crushing against our body is that the pressure, that is the blood pressure from inside our body, is equal to that of the surrounding air. That is, it is equal to the pressure exerted by the surrounding air. So there is no net force for us to sense. The pressure of atmosphere is not uniform, and this atmospheric pressure is generally measured by a barometer, and the measurement of changing air pressure is important for meteorologists for predicting weather. And do you know one thing? Atmospheric pressure is maximum at the surface of Earth and decreases as we move upward. So the value of the atmospheric pressure at sea level is somewhere around 1.013 into 10 to the power Newton per meter square. So let us have a quick summary of what we have learnt in this lesson. We have learnt to define force and what are the various effects of force, different types of force, and we have briefly discussed about friction, pressure, and pressure exerted on liquids and gases, and pressure exerted by liquids and gases, and what is atmospheric pressure. So here we have provided you with a few YouTube links which you can have a look in order to have an extended reading. Thank you, students.